Okay, I think I'm visible. Okay, so just wait a minute. Okay. Okay. So in previous class, so we are discussing about the searching technique. Okay. So before going into searching technique, I will discuss what are the different types of searches. Okay. So I will discuss about today. Okay. So basically there are two kind of categories. Okay. So one is uninformed. Okay. Uninformed, or we known as them brute force. Okay. Brute force search strategies. Okay. Search strategies. Okay. So they are basically the most simple kind of algorithm searching technique or searching algorithms. Okay. So basically they don't need any domain specific knowledge. Okay. They work fine with a small number of possible states. So they don't they you can there are lots of uninformed search techniques are there. So I'll give you some example. So BFS. BFS means breadth first search. Breadth first search. Then you have the first search, or you can call it DFS. Depth first search. Okay. Then the uniform cost search. Uniform cost search. Then you have depth limited search. Then you have iterative deepening search. Iterative search. Then bidirectional search. Okay. So these are kind of uninformed search. Okay, we don't know the strategies actually. Basically, in here we don't know the state or any kind of things. Okay, so I will explain these things later. Okay, I will go into deeper. Okay, so basically in this kind of strategy, I'll just give you an example: 0, 1, 2. In here, kind of, let's say we have to find out where we will find 6. So from 0 to 6, how we can get, or actually this is not the one. So let's say we have to search 6. Okay, in from this graph. Okay, I'll tell about the graph. Okay, so these are the algorithms to do that. Okay, how we will know where is 6 is. Okay, So that is one of the example. The next one is informed search. Second one is informed search or heuristic search. Okay, so basically these are the large problems with large number of possible states. Okay, so basically these problem specific knowledge needs to be added to increase the efficiency of search algorithm. So there are two kind of I'll give you greedy paste first search, okay, and two is a star search. Okay, let's say we have this type of graph. Okay, A B A D C. Let's say this is the root node. This is the actually starting point. Root means starting point. You can call this root, and this is the goal state. So here you know about the our journey. Okay, we have to find out the, let's say, smallest cost paths. Okay, let's say some cost will be in this path. Okay, 3 8 4 2 8 6. So from A to G we can go from any direction, A C F G, A C F G. From here we can go just like this, A B E Z. From this direction you can go, many directions are there, but we have to find out the minimum cost, actually minimum cost that will the path will cost. Okay, so these are the some algorithms. Okay, so basically there are two types of search strategies. One is uninformed search strategies, then next one is informed search or heuristic search. Okay, so before going into deeper, we have to discuss about the graphs. Okay, so anyone can tell me what is graphs? Graphs. So what is graph? Anybody? I'll see the answers. You can tell also.
Sir,
Yes.
graphs are collection of points between two or three coordinates.
Okay. Actually, basically, in mathematics term, graph is nothing but the collection of edges and vertices. Okay, that is the basic definition. Okay, so you can say a graph is a finite set of nodes with set of, you can say nodes or vertices. You can nodes, vertices, same thing. Which edges between vertices. Okay, so what are the vertices? Vertices, I'll give you an example. Is this a graph? So can you tell me which one of these are graphs? I have drawn, let's say, 1 2 3 and 4 figure. So which one is the graph? Which one of these are graph, or one or many?
Sir, 1, 3, and 4 are graphs.
Okay. So basically, actually, 2 is also graph. Okay. A point itself is a vertex with no edges. Okay. So that is also a graph. Okay. So all four are actually graphs. Okay. So basically, these are vertices. Okay. These are the connecting nodes, or you can say edges. So that is all are things about all are this four figure is graph. Okay. So I will. So basically, it's a finite set. Okay. So I'll say, can you draw this graph? Okay. I'll give you the both set. Vertices set is 0, 1, 2, 3, 4. Okay. Then edge set will be given also 0, 1. Okay. 1, 2, 0, 3, 3, 0. 2, 2, then 4, 3. Okay. So these are the okay. I'll just note. Okay. This is set of vertices and this is the set of edges. Okay. So we need to draw the graph. So how to draw that? Okay. Just first, just you imagine this is the point 0. Okay. And this is the point 1. Then this is the point, let's say 2 here. Okay, then you can put it anywhere, no problem. Okay, 3, then let's say 4. So now the edges between which of the two vertices? So 0 to 1. So we have to draw 0 to 1. Okay. Okay. Then tell me 0 to 1. We have done. Then 1 to 2. 1 to 2. So we have to draw 1 to 2. Okay. Then 0 to 3. 0 to 3. Okay. After that, 0 to 3 we have done. 3 to 0. 3 to 0 is already there. Okay. So we should not draw again. Or you can, if it is bidirectional, but if you give direction, that will be also a matter. Okay. If we give, let's say, there are two kinds of graph is there. Okay. I'll tell. One is directed, and one is undirected. Okay. Okay. So let's consider directed graph. This is kind of an example. These are the example of undirected graph. Okay. These are the examples of whether from this or this, from this or this, where from where to where we are going, we are not mentioning about in here. Okay. But let's say if we consider directed, then we have to give the direction. So from 0 to 1 we are going. So here just you, here you can draw, or here you can mention. Okay. Anyone is fine. Anything is fine. Okay. You give direction in this direction, then 1 to 2. Okay. 1 to 2. Then 0 to 3. 0 to 3. 0 to 3. Okay. But we have to go 3 to 0. In case of undirected graph, 1 is enough. Okay. 3 to 0, 0 to 3 will mean the same. But in here, if we consider directed graph, then we have to again draw 3 to 0. Okay. 3 to 0. That we have done. Then 2 to 2. 2 to 2. Okay. So itself it's a kind of a loop. So you have to grow 2 to 2. Okay. From itself. Okay. So 2 to 2, and then 4 to 3. So 4 to 3. So this direction. Okay. So this is an example of directed graph. Okay. So these are the example of undirected graph. So here direction is not mentioned. From point A to point B, direction is not mentioned. Okay. So, okay, next. So these are the basics of graphs. So I will give you an example, real life example. Okay. So where graphs use in many cases. Okay. Okay. I'll give you an example. So I'll give you a set. So a real life example. Real life example. Of graph. Okay. So there are two set will be given. So B will be set of 6 people. 6 people. Okay. Now John, Mary, Joe, Ellen, Tom, and Paul. Of ages, okay? Of ages 12, 15, 12, 15, 13, and 13 respectively. Okay, these are the vertices set. Okay, so E set means edges. Okay, so X, Y. If X is younger than Y. Okay. Okay, so now we need to draw the graph. Okay, so 6 people are there: John, Mary, Joe, Helen, Tom, and Paul. Okay, so draw. This is, let's say, I'll use defined color, so that will be this is Mary. Okay. And this is Helen. And green will be, let's say here, John. You can put anywhere, okay? John. Okay. Then let's put another color. Pink. So put John. And 2 more are there. That is Tom. And Paul. Okay. Now we have to draw the edges between them. So these are the people. So here John, Mary, Joe, Helen, Tom, and Paul. Okay. So we have drawn this point. Okay. Now what will be the edges? Okay. In which direction the edges will be there? So if X is younger than Y, okay, X to Y. So first consider in case of Mary. So Mary is, you just see, it is 15. So these two are Mary and Tom are the oldest. Okay, Mary and Tom, I think Tom. These are the oldest. So from Mary to another age will be not be there. So because this is younger than Y, okay. So from John, let's say we consider John, okay. John is 12, so he is younger than Mary, and this is Tom, okay, and this is 13. So 13, 15, and 15, and this 13, okay. So 13 is Paul. 13 is Paul. So now first we'll give a direction to John to Paul. Okay. See here, Paul age is 13. So it is, so John is younger than 13. Okay, 13 means Paul. John is younger than Paul because his age is, John age is 12 and Paul age is 13. Okay, so we have to give a direction. Okay, so we have drawn a ages. Okay, and many more are there. So from right side we are considering. So Paul is over. Now come to Tom. Okay, Tom is also young. Sorry, uh, John is John is younger than this Tom. So just put a direction to John. Okay. So any more there? So of course. So it's similar to, if it is younger, if it is the same, then we do not need to do anything. So 12 is same. So 15, which, so 15 is the age of Mary. So we have to give a direction to Mary. Okay. So any more? I think Helen is also old. Okay, so we have to give also to Helen. So this is from John to all other possible, okay, directions. So similarly you just draw. Okay, I will draw, just check whether it is correct or not. So basically in here we are putting ages from younger to older. Okay, so John is younger than Mary, John is younger than Helen, John is younger than Joe. Sorry, not Joe. John is younger than Tom, and John is younger than Paul. So that's why we are putting the ages between them. Okay. Similarly, you do for others. Okay. This is an example of real life example of a graph. Okay. So now, so why we need this kind of graph? Can anybody tell me? A subject is there in mathematics, I think, from which are from any mathematics background, they will know better. Okay, so graph theory.
Sir, to calculate the shortest distance.
Not only that, so to represent any relationship between anything. Okay, so you are related to, how you are related to other member, you can just search by your hierarchy, family hierarchy, that you can use. You can use graph. Okay, so in many cases, so graph is used. Okay, so you have to, let's say a network is there, computer network. So from one computer to another computer, how it is connected, let's say from point A, this is a computer, this is a computer B. Okay, so some other computers are there. So somehow you are connected to point A to point B. So that can be achieved. That representation is given by actually graph. Okay. So basically, graph can give any representation between any things. Okay, so how to represent these graphs in computers actually? Okay, so now we know what is graph. So representation of graph, representation of graph. So how to represent graphs in computers? Okay, because we cannot draw these kind of things, computer will not understand this thing. Okay, so mainly there are two types of representation. Okay, so one is adjacency matrix, representation, and one is adjacency list representation. Okay, list representation. So there are basically two ways. So how to represent a graph? Okay, so I'll explain. So matrix, you know, so M cross N, this is kind of a matrix. I think you all knows about matrix. Okay, so this represent rows, how many rows will be in the matrix, and column. So this is matrix. So how to represent? Talk about this adjacency matrix. Okay, so let's to 2. So I'm first considering an undirected graph. Okay, graph also. So this is the undirected graph. Okay. Okay, undirected graph. So basically we have to find out the adjacency matrix. Okay. Okay. So basically how to do that? So we have to, I'll given a this thing definition. Okay, but I will explain. So what is adjacency matrix? I'll tell. Adjacency matrix A n cross n, where n is the number of vertices. Okay, n such that a I equal to 1 if I and j are adjacent. Okay, I'll explain it, don't worry. Otherwise, okay, so how to represent this graph? Okay, in adjacency matrix. Okay, are you able to see now? Yes, I can see. So let's see. So here how many vertices are there? 1 2 3 4 5. So just write down. So it's a adjacency matrix A n cross n. N cross n means number of vertices. Okay, how many vertices? 5. So just write 1 2 3 4 5. Okay, and here also 1 2 3 4 5. Okay, so we have to now check how to make this adjacency matrix. Okay, so from 1 to 1, is there any loop between this kind of things? Is there? No, it is not there. So that's why we will write here. You just see here, just you see aij. let us consider this is I and this is J. Okay, so 1 1 is this adjacent. Okay, there are no edges between the itself, there is no loop in between, so it will be 0. Okay, so from 1 to 2, so 1 to 2, if I and J are adjacent, so basically if there are any edges between these two, just write 1 1 to 2, it is there, so 1. So 1 to 3, is it there? 1 to 3 directly not there, so 0. Similarly 1 to 4, it's there, so write 1. 1 to 5, is there any edges? No, so it will be 0. Okay, can you wait. Okay, can you tell me the next one from 2? This is 1, this is 2. Okay, so can you tell me 2 to 1, so what will be the value? Can you tell me this row? Check.
1, 2
2
to
to
1
1.
1,
Okay, 2 to 1 1, then
2 to 0,
then
2 3 1,
okay,
2 4 1, 2 5 0.
okay. So similarly for 0, for 3, sorry, it is
3
3 2 1 0. So I'll write it down, just check whether it is okay or not. Okay, 1 1 0 1 1 0. So basically this is the representation of this graph. Okay, this graph, if I give you any graph, can you do? I think it's very easy, just check once. Okay, I'll give you some time. So basically from 1 to 1 there is no graph. If it is there, let's say if it is there, then 1 to 1 will be, it will be 1. Okay, because a self loop is there, so that's why we are writing as a 1. But in this case there is no self loop, so that's why we are writing as a 0. So I'll just remove this. So I'll draw this graph again if you get confused. I'll draw the graph again. One, two, three, 4, 5. Okay. So I'll give you some time to see the matrix. Okay. Okay. I'll just give you a matrix or give you a graph, then just you do the adjacency matrix. Okay. This is the directed graph I have given. So can you draw the adjacency matrix of this graph? So we take adjacent matrix A. So what will be the matrix? But after making the graph, just remove this 1, 2, 3. This is for your help actually. This is the original matrix. Okay. If I told you to write this matrix, write only this matrix only. Okay. Just remove these things. Okay. Remove these things after making. This is for your help only. Try to do that. Okay, I'll do that. So okay. So we have to start from 0, 1, 2, 3, 4, 0, 1. Okay. So I will give an insight. Okay. So if there is no loop is there na, so this all will be 0. Okay. See, this all diagonal elements will be 0 if there are no self loop involved. Okay. It is a kind of a, you can call as a trivia or property. Not trivia, this is property actually. If there are no self loop, if there is no self loop, then diagonal elements will be 0. Will be 0. But in this case, it is not. Okay. Can you tell me first row?
0, 0, 0,
0, 0 to 1.
0 to 1, 1, 0 to 2, 0, 0 to 3, 1, maybe,
Okay. Then
0 to 4, 0.
okay. Okay, sorry. I'm writing one more. Then 1 to 0. The second row, any other can tell. One to 0, is there any part? No. Direction is not on that direction. Just to notice that. Okay. There is between 0 to 1, but not from 1 to 0. So that's why 1 to 0 is will be 0. Okay. From 1 to 1, is there any self loop? No. So 0. So then 1 to 2, it's there. 1 to 3, is it there? Nothing is there. So 0. Then 1 to 4, is it there? Nothing. So 0. So similarly, I will write. So just check whether it is correct or not. Okay. 3. So 3. Okay, just check. From 3 only one direction is there. 3 to 0. Okay. From 4 only one is there. 0, 0, 0, 1, 0. Okay. This is the adjacency matrix. You can later remove these things. Okay. This is for only convenience. Okay. Just check whether it is correct or not. I think everyone got the concept of this adjacency matrix. Okay. Any more question in this regard, adjacency matrix? Okay, if I give you any graph, then you can do, I think. Okay, so what will be the benefit of this? Okay, pros and cons. Okay, so pros will be, I'll write this down. So basically it is simple to implement. Simple to implement. Okay, then next, easy and fast to tell if a pair means the edges between two vertices. Okay, pair is an edge. By looking at the graph, you can easily check. Simply check if Aij is 1 or 0. Okay, this is the pros. So cons. Okay, so I will tell you. So there are two types of things in computer science. So to measure the complexity, in the last class I have told about p is equal to n or not. Okay, two types of complexity is there. So I will not go into details. That is the one chapter of this data structure and algorithm. Okay, so that is complexity. Complexity, you can say, I will just tell you. Okay, complexity of a problem. So there will be two complexity. So let's say I will tell you that you do remove these shares from this place to that place. Okay, so there will be two complexity. Okay, so I will tell you. So what will be the my requirement? One requirement will be that you use less space. Okay, and you do it quickly. Okay, do it quickly is basically time complexity. Okay, one is time complexity. So why I'm telling this, and one is space complexity. Okay, so in here the cons will be it will require more space. Why more space? Cons. Complexity will be n square. Why n square? So I'll tell you. So if the number of vertices is n, in here is also n. So how many will be there? So n into n square. So n square amount of space is required to fit this in computer memory. If it is a large matrix, so it will require much big memory. Okay, so if it is a complex graph or it's a big graph, then it will require more memory. Okay, so what I mean to say, in here just you see five vertices are there: 0, 1, 2, 3, 4, 5. Okay, in here also 1, 2, 3, 4, 5. Okay, so n is 5, n square is 25. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So n square space is required to store this adjacency matrix. Okay, so if the n increases, then it will increase the space will also increase. Okay, so if it is 4, 5, it is 25. But if it is n is a large number, very large number, let's say 1 2 3 4 5 7 8, this type of number, so n square will be a big number. Okay, so that will be a difficult for computer to store, okay, or to compute. So that is a con of this adjacency matrix. Okay, so next I will tell you about the, so I have tell you about the this adjacency matrix. Now I tell about the adjacency list. Okay, so list, so what is a list? So I will just write it down. So do you know linked list? Anyone, do you know linked list? Have you heard the term linked list?
Yes, sir.
Okay, so basically in computer science, let's say, how I explain this. Okay, this is a basically list. Okay, it's a kind of a data structure. Okay, so where we store numbers or anything. Okay, so these are the kind of a memory thing. Okay, this will point to the next memory pointer. Okay, this type of things are there. So this is a linked list. So we'll not go into deeper because it will be again data structure. So I have to explain again linked list stacks. Okay, so just think it is a list. Okay, so I will tell you. So how to do this in case of graph matrix? You understand? No problem, I think. So I'll again draw the graph. Okay, same graph. 1 2 3, okay, 5 10 4. So this is the graph. Okay, so this is an undirected graph. Undirected graph. Okay, we need to find out the adjacency list. Okay, how to do that? Okay, so first we will consider vertex 1, L1. So what will be the list? Okay, for 1. Okay, here you just see from where to where it is going. From 1 to 2 and 1 to 4 it's going. Okay, so we have to draw the edges between them. Okay, so basically just draw this type of list. 2 and 4, because 1 is going to 2 and 4, not 3, not 5. Okay, then for L2, just say, okay.
Sir,
Yes, tell me.
sir, why you have drawn a empty box before 2 and 4 in L1?
Actually, this is not there. You should not draw. Actually, I'm just drawing it for. You can just represent it like that. Okay. 2 and 4. 2 and 4, and then for 2 and 1. Okay, 2 and 4. So you can think at it as a, if you do not draw like this, just remove this, just remove. You can also represent it like this, 2 comma 1. Okay, then after from 2 you just see where it is going, from 2 to 3, 2 to 3, 2 to 1, then 2 to 4. Okay, 1 3 4. So you just write 1. Also this is 4. Okay, this is 4. 1 3 4. Then for L3, so L3 you just write 5 2 and 4. Okay, so basically 2 4 5, 2 4 5. No, okay, basically these are represented in, stored in linked list. That's why I'm drawing like that. Okay, you can write it like that also, not a problem. So this is for your understanding only. Okay, 2 4 5, then L4. So now we come to 4, just check. Okay, 4, what will be the answer? Just tell me.
1, 2, 3,
1 2 3 and 5, and for L5 it will be, just check. Okay, 5 from where, from 5 where it is going, 3 4, is there any? No, 3 and 4 only, 3 and 4. So these are the list to represent this graph. Okay, if I tell you this list, then you will easily able to draw the graph also. Okay, so I'll give you an example. Okay, if you want to draw, then please draw. 1 sorry, I'll just use this. Okay, because my drawing is not so good. Then sorry, it's too complicated. I'll draw it here. Okay, now from 2 I'll draw. Actually this is in direction only. Okay, Okay, this is the one. Okay, just try to throw the list. Okay, I'll just tell you some example. L0, what will be the L0? Just check what is will the L0. So L0, all are coming towards the 0 only. Nobody is going, nothing is going from 0. So it will be empty or null, you can write. Okay, so then for L1, it is anything going, no, all are coming, all the edges are coming towards 1, not any one of the edges will outwards you can say. This is inwards. Okay, this is inwards, nothing any outwards edges is there, so that's why it is also empty. Now for L2, just check. So L2 we can see here, L2, so up to 0, 4, 5 and 1. Okay, 0, 1, 4, 5. Then L3, just check in the graph. Okay, L3, so 3 is 0, 1. This is the 3. Okay, from 3 where it is going, 1, 5, then 4, then 0. So it is same, 0, 1, 4, 5. For L4, yes, L4 just check for 4. So it is coming, so it will not consider this. This is going, so 4 to 1. Any other? No. Oh, 1, 0. This is also going, 4 to 1. So 0 and 1. For L5, from 5 where it is going, this is going to 1 and this is also going to 0. So same, 0, 1. So this is the link list or adjacency list representation of graph. So can you do, if I ask you any question in the exam, can you able to do this? Is there any problem? You can ask. Did you got it? Is there any doubt in this list?
No, sir.
Okay. Okay, and then next class we will discuss about BFS and DFS. Okay, DFS. So BFS means breadth first search and DFS means depth first search. Okay. So this is a two basic search techniques. So why I'm discussing this matrix things or graph things, because you need that thing for this algorithm to understand. Okay, so just go through. So I'll just share this as a PDF. Okay. Okay. Thank you.
Everybody.